We're going over the Chapter 8 review. The first problem is an expression, and the operation is addition. So we think through the common sense rules for addition. To add or subtract, the names have to be the same. In algebra, we call them like terms. With fractions, we say that we need a common denominator. To get the common denominator, you find the least common multiple. To find the least common multiple, we do the prime factorization. So we're going to do the prime factorization of both original denominators. So the first one, 2 will go into 54 27 times. Divided by 3 is 9. Divided by 3 is 3. And so 54mn to the fourth, written as the product of its primes exponentially, is 2 to the first times 3 to the third times m to the first times n to the fourth. 36 divided by 2 is 18. Divided by 2 is 9. Divided by 3 is 3. So 36m squared n, written as the product of its primes exponentially, is 2 squared times 3 squared times m squared times n to the first. We now do what that line on page 8 says. You might want to refer back to that for memory work purposes. It says you take the largest power of each prime. Of the prime 2, the largest power was a square. Of the prime 3, the largest power was cube. Of the variable m, the largest power was square. Of the variable n, the largest power was the fourth. We've taken the largest power of each. We found the largest power of each. And now we're going to multiply those. That will be our common denominator. 3 cubed is 27. 2 squared is 4. 27 times 4 is 108. So we get 108 m squared n to the fourth as a common denominator. But still we got a common denominator. Now it is time to make equivalent fractions. So we're going to take the original fractions, 5 over 54 m n to the fourth, plus 3 over 36 m cubed n, converted to the new denominator of 108 m squared to the fourth. To make equivalent fractions, we think old denominator times what gives me new denominator. And we think about the rules for multiplication on page 5. And those rules for multiplication say you multiply the numbers and you multiply the names and you get a new name. And when you multiply with like bases, you add the exponents. So thinking of the numbers, we think 54 times what will give us 108. The answer is 2. And then you multiply the names and you get a new name. And when you multiply with like bases, m times m's, you add the exponents. So we say m to the first times m to the what gives us m to the second. Well, 1 plus an understood 1 would be m to the second. So we have an m to the first. And then we do our n's. N to the fourth times n to the what would give us n to the fourth. Well, we've already got 4 n's, and we're trying to get to 4 n's, so we do not need any more n's. So we multiply by the factor 2m, which gives us 10m for the new numerator. On the bottom, we think old denominator times what gives me new denominator. And I'm thinking about the rule that says you multiply the numbers and you multiply the names. So I'm thinking 36 times what is 308, and the answer is 3. And the last part of that is you multiply the numbers and you multiply the names and you get a new name. And when you multiply with like bases, m stuff times m stuff gives us m stuff. And that's an m cube I just figured out that I saw as an m square when I brought it down. And y'all probably recognize that. So that should have been a cube. So that should have been a cube. And so my common denominator has an m cube. And so I've got to go back to here. M to the first times m to the what would give me an m to the third, and that would be an m square. So I need to multiply by an m square. So I get 10m squared. And then we're thinking m to the third times what will give me an m to the third. I obviously don't need any more m's. And then an n to the first times an n to the what would give me an n to the fourth, and that would be an n to the third because n to the first times n to the third. You add those exponents, and that'd take you to 4. So we need to multiply by 3n cubed, and we get 9n cubed. Now we have a common denominator. When you add or subtract, the name stays the same, so we keep that common denominator, 108m cubed n to the fourth. We're trying to combine the numerator, which has 10m squared and positive 9n cubed. M squares and n cubes are not like terms, so the numerator becomes the expression 10m squared plus 9n cubed. And we have that all over 108m cubed n to the fourth. Any questions on example 1? Sorry about the little mistake in that. Okay. So we simplified the expression by combining like terms. Before we could combine those like terms, we had to get a common denominator. Number 2, we're solving for x. Our operation is addition, but this time it's not an expression, it's an equation. And so we recall back on page 232 where it said to solve a rational algebraic equation, you find the common denominator, and then you multiply through by that common denominator. We realize we have binomials here, and we realize that here we have a quadratic that we're going to have to write as the product of two binomials for cross-canceling purposes, but we're also going to have to write those exponentially, and so x minus 5 exponentially, and I think in the former examples I didn't put the parenthesis to start with, would be written as the binomial x plus 5 raised to the first, and x plus 2 would be written as the binomial x plus 2 to the first, and that was an x minus 5, and I just wrote it as an x plus 5 for who knows why. So let me fix that. So x minus 5 becomes the binomial x minus 5 to the first, and x plus 2 becomes the binomial x plus 2 to the first, and x squared minus 3x minus 10 becomes the product of two binomials, which we have to find and stick in a little skinny spot. Now, remember, we taught you something where you didn't have to use the full AC method if the A was 1. We said if A was 1, we were just going to say what will multiply to give us negative 10 and add to give us negative 3. And we can think a little bit and realize that that would be a negative 5 and a positive 2. Negative 5 plus 2 is negative 3. Negative 5 times 2 is negative 10. So that would factor into those two factors, which are the two factors we would get over here, both to the first power when we write those exponentially. Now, what we do at this point on the LCM drill, which we learned on page 8 in the very beginning, is to take the largest power of each and multiply. The largest power of x minus 5 was x minus 5. We had two of them, but we only take one. The largest power of x plus 2 is x plus 2 to the first. And so my common denominator would be x minus 5 to the first times x plus 2 to the first. And we would actually multiply those binomials according to page 200, except we're wanting to see the factors so we can cancel them. So in this particular application, we just leave them like they are. I'm going to take that out of my way. And so we found a common denominator, and so we're going to multiply each term by that common denominator, even though we're leaving it written as its factors. And so we're going to have times x minus 5 times x plus 2 on each one of these. Now we start our cross-canceling stuff. X minus 5 cancels x minus 5. What we have left here is a 1 times x plus 2, which is just an x plus 2. On the second one, the x plus 2 cancels the x plus 2, and we have a 3 times x minus 5, so plus 3 times x minus 5, which we write like that. And then we've got our equal sign. The x minus 5 cancels the x minus 5. The x plus 2 cancels the x plus 2, excuse me, and the only thing left is a 31. And so we have that expression on the left equal to 31. We want to simplify the expression on the left, and we'll do that by distributing first. We get x plus 2 plus 3x minus 15 when we distribute equal 31. We will now combine like terms, x's with x's and numbers with numbers. X and 3x is 4x. 2 and negative 15 is negative 13 is equal to 31. Now we're going to undo. We have multiplication and subtraction. We will undo subtraction by addition, so we add 13. We get 4x is equal to 44. We will now undo multiplication by division, and we get x is equal to 11. I'm going a little faster going over some of this basic algebra because we're almost to the end of the book. We should all be fast at it by now. If that's too fast for you, then pause the tape. Just pause it, get caught up with your thinking, your writing, and then keep going. And you know that by now too. So I'm just moving a little faster here as if I was teaching Algebra 2 or college algebra. Okay. Question number 3. Question number 3, we have multiplication. We know from page 5 that to multiply, you multiply the numbers and you multiply the names and you get a new name. But here we're dealing with an equation, a rational equation involving multiplication. And so we know what we do if we think back to our chapter 8. We find the factors of each of those, and then we're going to cross-reduce as much as we can, see what's left, and solve accordingly. I'm going to go ahead and take the number of the problem out of the way so we're not letting that bother us. Now, what we need to do is factor everything we can. We do realize to begin with that these are binomials, and so we're going to go ahead and put those parentheses. And then these two are quadratics, which will factor into two binomials, so we need to do that. And then we'll go from there. The x minus 25 should be viewed as x minus 5, both squared, x squared minus 5 squared. From page 204 in the text, we know that the difference between two squares factors into those two things, with one a plus and one a minus, the x and 5 in both, plus in the first one, minus in the second one. We call those binomial conjugates. So the difference between two squares factors into the binomial conjugates. We learned that we didn't have to use the AC method on page 213 to factor a quadratic if the A value was 1, which it is. And so what we're going to do is look for the numbers that multiply to give us 45 and add to give us 14. And we know that that would be a positive 5 and a positive 9. So we're going to have a plus 5 and a plus 9. 9 plus 5 is 14, and 9 times 5 is 45. So that factors into those. Once they're factored, we can start the cross-reducing process. This x minus 5 down here cancels with that x minus 5 up there. This x plus 5 down here will cancel with that x plus 5 up there. And what we have left on top is an x plus 7. And what we have on bottom left is an x plus 9. And on the other side, we had the fraction 11/13. What we have is a proportion. We learned about those on page 55, and there's an example of a proportion that looks like this on page 58, and we learned to solve those proportions like this. You cross multiply, we have 13 times that sum, and so we put that sum in parentheses, and we'll distribute in a moment. We have 11 times that sum, so we put that sum in parentheses, and we will distribute in a moment. So now we simplify each side by distributing. We're going to have 13 times x is 13x, and 13 times 7 is 91. 11 times x is 11x, and 11 times 9 is 99. We've done all we can to simplify either side down as far as it'll go. And so now we do what it says on the bottom of the order of operations horseshoe on page 33. It says we get the variable that we're isolating on one side of the equal sign, remembering to change the sign when you cross over. So we get 13x minus 11x is 2x, plus 91 is equal to 99. We have multiplication and addition. It's time to undo. We will undo addition first by subtraction. We're going to get 2x is equal to 8. Now we undo multiplication by division, and we get x is equal to 4. You could plug it back into all of that and verify that it does turn out to be 11/13. Any questions on example 3? Okay. Example 4. Example 4 is a division. We know that to divide by a fraction, you reciprocate and multiply. This is a rational algebraic equation, and so we're going to think about those rules also. We'll do the same thing we did when we multiplied. We'll find all of the factors, except for when we're done, we're going to flip all the second one stuff and change it to multiplication. We should recognize x squared minus 49 as x squared minus 7 squared, the difference between two squares. And so we should quickly realize that that factors into the binomial conjugates, x plus 7, x minus 7. Again, we know a trick that if a is 1, then instead of going through the whole AC method from page 213, we can think, what can we multiply to get 16 and add to get 8? And we think about it a second, and we get plus 4 plus 4. 4 plus 4 is 8. 4 times 4 is 16. So those factor into x plus 4, x plus 4. Same kind of thinking here. Understood 1 for A If A is 1, we want to know what can we multiply to get 21 and add to get 10. With a little bit of thinking, we come up with a positive 3 and a positive 7. 3 plus 7 is 10. 3 times 7 is 21. So we know they factor into that. Same thing here. A is 1. What can I multiply to get 12 and add to get 7? And we quickly think of 3 and 4. 3 plus 4 is 7. 3 times 4 is 12. And so we know that that factors into that. So we got it all factored quickly because I had all the A's 1, so it made it easy for you to factor. But then we have to remember that when you divide by a fraction, that's the second one, then you reciprocate it and multiply. So we're going to change that division to multiplication, and then all the bottom stuff here goes to the top because we're reciprocating. And all the top stuff goes to the bottom. And the first one stays the same, so the top stays on the top. And the bottom stays on the bottom. And over here, we still got that fraction 2/13, so equal to 2/13. Now that it's multiplication, we can cross-reduce anything that'll cross-reduce. So this x plus 4 will cancel that x plus 4. This x plus 3 will cancel that x plus 3. This x plus 7 will cancel this x plus 7. What we have left on top is an x minus 7. What we have left on bottom is an x plus 4, and that's equal to this fraction over here, 2/13. Okay, we say we got that. We have a proportion again. We will solve that proportion by cross multiplying. We'll have 3 times x minus 7 is equal to cross multiply 2 times x plus 4. Those are called the product of the means as you go to the left, the product of the extremes as you go to the right. We will simplify the expression on either side by distributing. That will give us 13x minus 91 is equal to 2x plus 8. We've simplified each expression as far down as we can. So now we're going to get the variable that we're isolating on one side of the equal sign, remembering to change the sign when you cross over. And we'll move our problem over to here. 13x minus 2x would be an 11x minus 91 is equal to 8. We're going to undo subtraction by addition, so we're going to add 91. We're going to get 11x is equal to 99. Undo multiplication by division, and we get x is equal to 9. Any questions on example 4? Okay. Example 5. This is the fancy division problems that we learned about. Remember the 4 steps to division. See how many times it'll go. Multiply, subtract, bring down. And so for problem number 5, I'm going to circle it so it won't get in my way. And over here, I'm going to circle the number 6, and we're going to look at the processes. We're going to say how many times will 4 go into 23 yards, and we think about the name with it. 4 times what? How many times will 4 go into 21? Well, 3 4s are 12, 5 4s are 20. There we go, 5. But we need the name yards. So we see how many times 4 going to 23 yards. It'll go 5 yards times. When you multiply 4 times 5 yards, you get 20 yards. And then you subtract, which changes the sign, and 23 yards minus 20 yards is 3 yards. and then we bring down 2 feet. It's time to divide in the feets column, so we need to change those yards that we have to the feet that we brought down. There's 3 feet in a yard, so we multiply by 3 and get 9 feet. So we take the 9 feet from the 3 yards, added to the 2 feet we brought down, which gives us 11 feet. And now we're going to divide in the feet column. And so we say 4 times what will give us 11 feet. We say 2, and we put the name feet with it. And then we multiply 2 feet times 4 is 8 feet. And then we subtract. And then we bring down. It may bother you that there was 3 feet left over, but don't worry about it. Now we're going to be dividing in the inches section. So we could change those feet that were left to inches. There's 12 inches in a foot. That makes 36 inches from the 3 feet. Added to the 9 inches we brought down gives us 44 inches. So now we say how many times will 4 go into 44 inches, and it'll go 11. 11 inches times. That goes up here. And then you multiply 11 inches times 4 would be 44 inches. And then you subtract, and that's a 0, and so it divided evenly, 5 yards, 2 feet, 11 inches. So we use the 4 steps to division. See how many times it'll go. Multiply, subtract, bring down. When you bring down, you have to take what you had left of the other one and convert it so that everything turns out to be the next unit over. Then you work with that unit, convert to the next unit, work with that unit, convert to the next unit. Okay? All right. Number 6, the first thing we want to remember is that this is understood parentheses. We're dealing with a binomial being divided into a polynomial. To do that, we still use the 4 steps to division, but we have to think about this one thing. You look at with the first. And so we say, how many times will the first go into the first? X times what is 5x squared? And the answer would be 5x. And then we have to remember that when we go to the next step, which is to multiply, that we distribute. So 5x times x is 5x squared. And 5x times 4 is 20x. When you subtract, you have to remember to change both signs. Combine like terms using sign rules. The 5x squares cancel. On the x's, we get -7. And then we bring down, and that's the 4th step, so it's time to start again. So now we see how many times it'll go. We look at only the first with the first. How many times will x go into -7x? The answer is -7. And then you multiply, remembering to distribute. -7 times x is -7x. -7 times 4 is -28. And then we subtract, which tells us to change the sign of both. That cancels, that cancels. You have a 0 remainder, so it divides 5x minus 7. Any questions on the first 6 problems of the Chapter 8 review? We're going to stop there, and then we're going to make the table and graph part a second video on this review.